This is a video about geometry with a focus on points and lines. First of all, notice that my page is a flat surface, and a flat surface in geometry is called a plane. And on the plane, I can mark points. And if I want to make it clear which point I'm referring to, if there's a number of different points on a page or on a plane, then it's a good plan to give them all individual names. So I've decided to call these points the points A, B, C, and D. So now when I talk about the point C, it's obvious that I'm talking about this point here. You might notice that the points A, B, and C are all in a straight line. So if I was to put my ruler down, A, B, and C would all line up. When I have points like this that line up on the same line, those points are called collinear points. If I have 2 points on a plane, I can use them to draw a line. But there's a number of different types of line that I can draw. Here I have 2 points. I'm going to call them the points E and F. And I can draw a line that goes through E and F. To show that this line could keep going in both directions infinitely, I can put an arrow at each end. A line that keeps going forever in both directions is the official definition of the word line. But I might not always have a line that continues forever in both directions. I might, for example, have a line segment. To explain what a line segment is, I've put in 2 new points, G and H, on my plane. A line segment is part of a line, it's a portion of a line that exists just between 2 points. So in this case, the line segment GH is just the line that goes from G to H, and I don't go out beyond those points. I might want to refer to this line or this line segment by name, and I can do so using a little bit of notation. For a line that keeps going in both directions infinitely and passes through 2 points, such as this guy here that goes through E and F and keeps going in both directions indefinitely, I simply name it by using the letters that are on it. So when I write EF, I mean the line EF that keeps going in both directions forever. The way that I write the name of my line segment is slightly different, because I want to indicate somehow in my written notation that I must stop at G and stop at H. So the notation for my line segment looks like this. I still use the names of the points, but I put a square bracket at either end to indicate that I must stop there. The square bracket operates kind of like a red traffic light that I can't go past. And there's a third type as well, called array. So to explain what array is, I've marked in 2 more points. I've called them J and K. Just as a little side note, notice how I went from H to J and I didn't use the letter I to indicate the name of a point. Why do you think I did that? Well, it's because I looks an awful lot like the number 1 and I want to avoid a bit of confusion. So oftentimes you'll see the letter I getting skipped as the name of a point. Anyway, I've got my point J and I've got my point K, and array is different from a line and a line segment. So I'm not going to draw something that goes through it and keeps going in both directions. And I'm not going to just join up J and K. What other options do you think I might have? So I could start at one of the points and then keep going through the other point. Have a think for a moment about how you think I should write this down using notation. I would name this ray JK, but I'd put a square bracket at the end where J is to indicate that I don't go out past J. Here's a second ray. How do you think I would write its name down? Pause the video for a moment, write down what you think the answer should be, and then check and see if you're correct. I could write this as LM, and again the bracket is on the side where the M is to indicate that I would have to stop at M. So when we talk about lines, there's 3 possibilities. There's the line, which keeps going in both directions indefinitely. There's a line segment, which just goes between 2 points. There's a ray that starts at 1 point and travels through a second point. And again, just notice the different ways in which we name them using symbols or notation. The last thing that I want to refer to in this video is the idea of the length of a line. So the line and the ray both continue infinitely in one or two directions. So the line keeps going forever to the left and to the right in this case, and this ray keeps going on forever to the right, and this ray keeps going on forever to the left. I've stopped, obviously, because I didn't want to keep drawing a line that went on forever. I wouldn't have enough space in any case, but my arrow indicates that it does keep going on forever. So if the line and the ray continue on infinitely, well, it's not possible for me to measure their length. So the only one of these three that I can measure the length of is the line segment. So here I have a line segment and it goes between N and P. So if I want to write down the name of this line segment, how do you think it should look? The name of this line segment is NP, and the square brackets either end, of course, don't forget, indicate that I stop at N and I stop at P. So since this line segment is finite, it has finishing points, I can find out how long it is. So I'm going to use my ruler to measure this as accurately as I can. And in this case, it looks to me like NP is about 5.4 centimeters long. But I can actually use notation to indicate that I'm talking about the length of NP. So I don't have to say in words, the length of NP is 5.4 centimeters. I can write that in a much shorter way. I do this by putting two straight lines on either side of my points N and P. And whenever I see two letters written down with two straight lines either side, that means that I'm talking about the length of the line segment that has this name. So just notice for a minute, when I'm just talking about the name of the line segment, I use this notation. So, there's the line segment NP. So I'd write it down with square brackets. But when I want to say NP is 5.4 centimeters long, then I say the length of NP equals 5.4 centimeters.